In this video, I want to talk about something that's related to the idea of the coefficient of determination. It's called the correlation coefficient. It's just a little bit different of a way of measuring the strength of a linear relationship between two variables. So what it does is it gives you a number between -1 and 1 inclusive, so it could be -1 and it could be 1 or any number in between those. And I'll explain what each value means in here. But the way to calculate this number there's two ways of doing it. If you remember from previous videos, we know what SXX and SYY are. So if you have those lying around, you can just calculate R this way. Or if you have R squared, it is just the square root of R squared, and the sign is the same sign as B1, as the slope of your regression line. So let's do two things here. Let's look at what these numbers mean. So we'll just do a little number line of numbers between -1 and 1, and do a few examples of scatter plots with a relationship roughly of values in between here. And then we'll look at the correlation coefficient of the data that we used in our previous example, that average hours of exercise per week and resting heart rate. Sorry, there's a typo here. This should be not SXX. It should be SXY. My apologies for that. So I wrote an X down there. It should be SXY. Okay, so here's a number line between -1 and 1, and these will be our R values, our correlation coefficient values. And I'll draw a scatter plot kind of for each of these. So let's say that we had an R of exactly -1. So that means it's a very strong relationship, but it's also negative. And how strong is it? It is indeed perfect. So it's a perfect negative linear relation. So all of the points would lie exactly on the regression line. So that's what an R of -1 would look like. Maybe I'll write that down. R equals -1. Let's do something near +1. Let's do something way up here. So we'll call this 2. This was 1. So 2 will be down here. So this is going to be a positive relationship. It's not going to be exactly on the regression line, but the points are going to be very, very close to it. And it's a positive relationship since our R is positive, so the slope of our line will be positive. So maybe it'll look something like this. Something like that. So that's R, let's say that R is about 0.98, for example. Let's do a few more. Let's do number 3 here. So this will be R about 0.7, I guess. So maybe that would look something. It's a positive relationship, and it's still fairly strong, but not as strong as if it was 0.98. So that would look something like that. That's R is around, I don't know, let's say 7.8, just to give it a number. Then something down here, let's say that's about R equals -0.4. Well, now you're going to get in a negative relationship, but it's not going to be particularly strong at all. So maybe it looks, I don't know, something like that. It still looks negative, but there's a lot of variation going on. And then finally, let's look at something here, right at 0. This is saying there's no relation. So this is R is 0. So this is you can't discern a linear relationship whatsoever. If you were to draw a regression line or calculate a regression line, it'll look pretty much like a straight line. Or maybe it's not that there's no relation, it's that there's no linear relation. So maybe instead you had something that did have a pattern, but it wasn't a linear relationship. Maybe it was something like this, something like a quadratic relationship. And if you tried to fit a straight line through this and calculate a regression equation from it, it still might look something like a straight line. So hopefully that gives you a feel for what various R values tell you in terms of the relationship between your independent variable and your dependent variable. And just a quick calculation for that data set we've been dealing with. Remember we had this regression equation of negative 4.8077x plus 87.0193. And my suggestion is go back to the video where we drew a graph of this and look at the regression line so you can get a feel for how this looks and how linear the data looks. And again, it's only a few points, so it might be kind of hard to really see what's going on. In real life, you'd usually have more than 6 points to make a regression line, but just for the ease of calculation, that's why we only have 6 here. So we calculated in the previous video that r squared was 0.7512. So our correlation coefficient is just the square root of that, 0.8667, with the same sign, because it's a negative relationship, as hours of weekly exercise increase, then heart rate decreases, or resting heart rate decreases. So this negative there, that goes there. So you have the same sign as your slope. So we have negative 0.8667. Or if you want to calculate it using our formula, if you have these guys around. And just to be clear, in the first video, the intro to regression video, this was our green highlighted number, and this was our blue highlighted number. So you can go back to that video and look for where we calculated those. And that 400 comes from the previous video. That's our SYY. And if we calculate that, we end up with exactly the same thing, negative 0.8667. There might be some rounding differences here, but for our purposes, that's close enough. So we can say that our data is there's a negative relationship, obviously, and we'll say this is somewhat strong. So this is a somewhat strong negative relationship. And different fields of study have different cutoffs where they say an R is strong or weak or middling. So it's really context dependent what you call strong for R. But for our purposes, we'll call it a somewhat strong negative relationship. This is pretty close in magnitude to 1. It's definitely negative, so it's a negative relationship.